My name is Steve Holland from the Milwaukee School of Engineering, and this video will provide a brief overview of our usage of the Analog Discovery Board in our electrical engineering program. When the Analog Discovery Board was first introduced, it really caught our attention. After all, here's a device that is the cost of a textbook, the size of a calculator, and has a full measurement suite on board. It allowed us to pursue a new goal. We wanted to make measurements more accessible to our students, allowing them to do measurements anywhere. Initially, we utilized the Analog Discovery Board in introductory circuits and digital logic courses, but most recently we have been expanding the domain to our upper division junior and senior level courses, where, in addition to portability, the Analog Discovery Board's network analyzer and spectrum analyzer allow for unique explorations of core concepts. This table shows some of the experiments developed to date using the Analog Discovery Board in our upper division courses. Note that the experiments make full use of the various measurement tools on the board. This video will focus on experiments from our electromagnetics courses. Transmission line effects can seem rather abstract to students. After all, up until this point, they've assumed signals instantaneously travel across their circuit. The following experiments provide a hands-on experience with time delay and impedance effects. This sample scope measurement shows a transient wave that is launched onto the cable and then propagates through to the output, where it is reflected back to the input due to the open-circuited load. Students can directly measure the one-way and round-trip delays through the cable. By adding a series resistor, the input impedance of the open-circuited cable can be measured versus time using the scope channels. Students see for themselves that initially the input impedance equals the characteristic impedance, but once the reflected wave reaches the input, the impedance jumps up to an open circuit. This helps them understand and differentiate between the characteristic impedance and total impedance on a T-line. It also shows why a multimeter is unable to measure the characteristic impedance directly. Finally, using the network analyzer function to measure the channel voltages over a swept frequency range, the phasor input impedance of the open-circuited cable can be measured as shown below. This essentially turns the Analog Discovery Board into a portable, one-port impedance analyzer. Overall, our students have truly embraced the Analog Discovery Board in our program, from introductory courses up through senior electives. However, the Analog Discovery Board is not perfect. The measurements are not the same quality as our expensive, immobile bench equipment, and experiments must be designed with this in mind. The Analog Discovery Board is really a supplement to our bench equipment, not a replacement. That being said, we have found that when properly accounted for, the lower fidelity of the measurements is far outweighed by the educational benefits.